Hey, this is OXDF, and we're doing the revival of Code 2023, which is the advent of Code 2020 or 2016. And this is day 2, bathroom security. It's an interesting challenge that involves moving around on a keypad, and the keypad changes shapes between part 1 and part 2. It's a fun Python challenge, and let's go ahead and dive in. All right, let's take a look at the challenge here. So we've arrived at the headquarters, and we've got to go into the bathroom door, and there's a code on it. So basically, there's a code pad that looks like this: 1 through 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we have secret instructions that we've smuggled out that give us up, up, left, right, right, down, etc. And so the way we apply that is it says for the first line we're going to start at 5, and so if we have up, left, left, we're going to go up to 2, left to 1, and then if you would go off the page, you just stay where you are. So then our first digit will be 1. Now we're going to do right, right, down, down, down. So we do right, right, down, 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 which effectively leaves us at 9. This time we're going to do left, up, right, down, left, left, up, right, down, left, puts us at 8. And then up, 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 down. So 4 ups and then a down puts us at 5. So 1985 is our code. And you can see that's the code for this example. And we're going to obviously have a much longer puzzle input. I'm going to go ahead and grab this here because we're going to use that. Let's go ahead and jump over into VS Code. I'm going to use my genday script here. I went over this in my introductory video going into this season. And also you can go to there's a link in the description, which will give you the GitHub repo that has all this code in it. You can check it out to your heart's content. What it's going to do here is it's going to pull the input for me right here, as well as give me some stubs, a test file and a Python file to work out. Looking at the input here, we can see much longer lines. If I word wrap this here, we can see, much longer, but not like too long, but something we want a computer for sure. There's 5 lines and there's an empty line at the end. So it's gonna be a 5-digit code for sure. And I think that's about all we need. We'll go ahead and close this. We're doing test-driven development, so we're gonna start with a test file. We're not gonna open up any files as fixtures here, so we can get rid of that. We're going to currently, if I were to run PyTest right now, we're just going to see 6 skip tests. That's because I've got 2 test functions, test part 2 and test part 1, and each one is parameterized with 3 inputs. Now they're all dummy empty inputs, but 3. And so that's why there's 6, and they each run 3 times. And then they're each currently marked with skip because they're not implemented. So we're going to go ahead and remove the skip from part 1 because we're going to work on part 1. And we're going to go ahead and add in the part 1 test case we're given. So we'll put this right here. Now, again, this is if I had much longer test cases, perhaps I would want to, just read it into from a file. But 4 lines, I can make that look okay right there. I'm going to add this new line to the end just to make sure I take into account that I might have an extra new line in my input. Over here, my result is going to be 1985, and I don't need any of this other. So, what have I just set up? Basically, now I'm only going to have one. This is going to run once. It's going to have the input of this stuff. All that stuff is going to get passed to my aoc.parse function, which we can see aoc is from the day2. So this day2.py, it's going to find the parse function. It's going to pass this input into that. The result is going to be parsed input. Then parse input is going to be passed to the part1 function, and the result is going to be expected. Or it's going to match that the result is 1985. So far, I've not changed parse or part1, so they both just default return none. So if I run this right now, I'm going to see that this is going to be none is equal to 1985. And so we can do that. Just up arrow. We see right here, assertion error, none is equal to 1985. That's not true, so my tests are failing. Let's go make them not fail. In here, the stub, again, I went over this in detail in the first video, but just, basically this part down here is if I run this file directly, read in input.txt or some other file I give it, get the input, pass it to solve, and then print the solutions. Solve is simply going to take the input given, put it through parse to get data, and then put the data into each of part 1 and part 2, returning those solutions. And then parse, part 1 and part 2 are the things I got to write. Parse, there's not a lot to do in this one. It's pretty simple, but we'll go ahead and break the lines up at least. If we look at, see if I open this, open to side. Beautiful. So I can at least get these lines separated. So I can do puzzle input dot split on new line. Whoa, what happened there? Whoa, that was wild. On new line like that, and then that's really all I need. So So for part one, what I want to do, I'm going to go ahead and look at this. We're going to draw out here a second. If I've got the pad looks like this, 3, 4, 5, 6, 7, 8, 9. What I'm going to put this into like a grid system. So I'll make the top one 0, 0, and then my x, y. So x becomes 1, 0, and this becomes 2, 0. The 4, therefore, would be 0, 1. The 5 would be 1, 1, and the 6 would be 2, 1. And then the 7 would be 0, 2, 1, 2, and 2, 2. And so if that's my case, if I treat those as the things, what I can now start to do is say, okay, well, what does a U mean? So I can do step map and just I'm going to make a map. So I'm going to say, if I get a U, then my movement is going to be no change in the X, or in the X, because I'm going up and down. And in fact, in this case, when I go up, my Y is getting lower, so it'll be -1. Now I can say, if I get a down, it's going to be very similar. It's going to be 0, 1. If I get a left, that's going to be, left will be -1, 0, and right will be 1, 0. So now I've got this map. I can set my starting places, x, y, and it said I'm going to start at 5, which is 1, 1, so I'm good there. And then I'm going to need my code, right? So I'll say code is equal to like this, and that's now I'm initialized. So now I'm going to loop. I'll say for line in data, and now I can say for C in line, because I can iterate over strings like this. What I want to do is say get the direction I'm going. So let's say I get a U. I'm going to update the X and the Y based on that. So I could do something simple. I could say X is equal to X plus step map of C 0, like this. And this is like a pretty close solution, right? Because now what I'm doing when I get an up, I will check my X here, 0, so X isn't going to change. And when I get a Y, I'll say Y equals that plus step map C of 1, and now it updates. The thing I don't handle here is going off the edges. And what I'm going to notice here is my X is always going to be between 0 and 2. So what I can really do here is say, I'll get my new spot, but I'm going to make sure that like what I really want is the min of this and 2. So that if I step into 3, well, then I just get 2. But if I step into 1, well, then the lower is 1. And then when I get that back, I actually want to also say the max of this whole thing, 0. So now, again, if I step to -1, well, when I do this max, I'll just shift back to 0, and that gets me there. So I can grab this whole thing right here, apply the same logic to the Y step, and then, so I'm going to do that for all the steps in the line, and then once the line's done, I'm going to say code is equal to, I'm going to do plus equals to, and then I need a string here, so I'm just going to make, I guess I need to figure out what my position is. The cool thing is, because I've designed it this way, this is going to be, this steps linearly where X is 0, 1, 2, and then if I make Y times 3, this would be 3, 4, 5, I can actually just get this with an equation. So I'll say X plus Y times 3, like this. And now, right now, that gives me 0, 1, 2, 3, 4, 5. I need to add 1 to that to get it into this 1-based system. So if I do that, now this code is going to get the digit I want. So that's going to do that after each line. And then after all the lines are done, I will return code. And I think I've just solved it. Let's try running our test and see what happens. We've got an error in here somewhere. We've got 1985 equals 1980 equals. So we've got an extra 5 here. Now this is interesting. This is why we test, right? Because what we did, if we look at our test, we have this extra new line here, and so it's getting a thing here of no moves, and it's just adding 5 again. So it might be worth doing a strip at some point. Let's see. Maybe we can take it off. Maybe we just do it right here. Dot strip, and that'll take white space off either side. And now that should remove that trailing new line before we split it. So that should get rid of that extra space. And boom, now we have our 1 passed and 3 skips. So we can say, if we come back up here and just hit F5 to run a Python file, we're going to run and we're going to get a result of 38961. Go back over here into Firefox and submit that. got our gold star. Let's go to part 2. I'll probably do a quick skip while I read this. Okay, so in part 2, the instructions stay the same, but the shape of the keypad is different. So now instead of having the 1 through 9 in 3 rows, I actually have 1 through D and in this kind of weird diamond shape. So we can still do the same thing. So like if we look at our example, we have the same example instructions here for our test. So up, up, left. We still start at 5. So from 5, up, nowhere, left, nowhere. So 5 actually stays at 5. Now when we go right, right, down, 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 we're going to go right to 6, right to 7, down to B, down to D, down staying at D. And what we're going to, so we have to just move around here the same way, but now we have new edges. Now we can't, just track to see, is X or Y greater than this thing, because we can't, we have this kind of diamond shaped. So we have the same thing. What is the bathroom code? We'll come here, let's see, DB 5DB3. Let's go, we'll start by updating our tests. So we're going to come here and we will do that here. And we want the exact same up to the quote mark here. So I can grab from here to there. Go ahead and clean up some white space, make this look okay. And then down we go there. So now we have our test case. We'll go ahead and remove the not implemented decorator. And now I should expect to fail on PyTest here. Let's go back to the bash one and run it. I should have 2 tests. One passes, the first test, and the second one's going to fail, and we can see it's saying that none is equal to 5db3. So we've got to fix that. Thinking about this one, the magic, I think the trick to this one's going to be, let's grab, if we look at this, if we set our coordinate system differently, so in this case, if we set our coordinate system so that the 7 is 0, 0, well, then we know that for a point to be in bounds, the total of this has to be less than 2. So for example, if this is 0, 0, this is, I guess we can go up or down for the sake of keeping, well, let's see. So if we make this 0, 0 kind of like a normal coordinate plane, so and we make up positive, down negative, right positive, left negative, then this becomes 1, 4, for example, becomes 1, 1. And 1 plus 1 is 2. And so as long as the absolute value of x plus the absolute value of y is 2 or less, then we're going to be in this diamond. As soon as we get over here, we're going to have something bigger, and we're going to try to step out of bounds. So we can use that as our check. It just means we have to kind of rethink our grid system. And so I'll try to draw it here. We can do x comma y. So minus 2, 2. And then we'll have minus 1, 2. And then we'll have 0, comma 2. And that's the first time we actually hit a, actually, let's get rid of some spacing here so we take up less space. 0, comma 2 is going to be our 1 space. And then we'll have 1, comma 2, and we'll have 2, comma 2. And so if this is 1 right here, I'll do one more line just to show. So we can do negative 2, comma 1, negative 1, comma 1, 0, comma 1, 1, comma 1, 2, comma 1. So the ones that are in bounds here would be this one, which is going to be our 1. And then here's 2, 3, 4. And you can see all of these, if I take the absolute value of x plus the absolute value of y, it's 2 or less. And that's what we're going to use as our key marker. So let's come up here and we'll do a similar thing. I guess we'll start down here. And we can say, we're going to need a different map. We'll get to that in a minute. We can start by saying x comma y, what is our starting place going to be? Our starting place is going to be 5. So that's going to be negative 2, comma 0. So negative 2, comma 0. We'll start with our code equals to something empty. We can say for line in data, for c in line. And now we're going to do our same kind of thing, except for now we're going to do like x2 is equal to x plus step map of c, comma 0. We're going to need to make a step map clearly. Y2 is equal to y plus step map of c of 1. And then we can say if abs x2 plus abs y2 is greater than or equal to, or is less than or equal to 2, x comma y equals x2 comma y2. So if it's too big, we just do nothing and keep moving. And then we can say, at the end, we say code is equal to plus equals code map x comma y. And we're going to need to map that somehow, right? So we're going to need to go from x and y back to this. And then we can return code. So the two things we're missing are step map and code map. Step map is going to look very similar to the one we had in the previous challenge, but I think we changed our coordinate system around, so let's be careful with it. When I go up, I'm actually going to go +1. When I go down, I'm going to go -1. And that's just because in this one, we started at 0, 0 at the top, and we made going right and going down positive. But in this one, we're starting at 0, 0, and we're making going up and right positive. So we just need to switch those there. I don't have a clever way to do code map. But basically what I need to be able to do is I need to be able to go from a point back to this thing. I don't have a great way to do it. I think we're just gonna hard code it, as annoying as that is. So if we have like 0, 2, we're gonna get the character 1. If we have, and this might take, I mean, maybe it'll be worth my just not pausing the video while I type these out. But basically, I'm gonna say I'm gonna get each of these spaces and convert them back. So I'll probably speed through this in a second. All right, I believe I've gotten it. So we start off at 0, 2, then we go -1, 1, -1. Oh, no, that's not good. -1, 1, 0, 1, and 1, 1. Yep. Then we go -2, 0, -1, 0, 0, 0, 1, 0, 2, 0. Then we're at -1, 1, -1, 0, -1, 1, -1. And then we're finally at 0, -2. And that's how we get D. So now with all of that, when I go to put that spot in there, I'll get back the code that I need, and I should be able to get the code. So let's actually, I think we might actually be done. Let's run this. And we have both tests passed. So we succeeded here. I come up here and hit F5 again, switch back over here, and I've got an answer. We solved it. Awesome. Neat little challenge. There's probably a smarter way to do the code map thing in part 2 than what I did, but it didn't take me more than a couple minutes to type that out, so it's probably not the end of the world. Unless you're trying to be like a competitive coder. So yeah, join me next time when we take on day 3 in a couple days. Thanks.